orbital. If last electron goes to p orbital, that is called p block. If last d goes to d orbital, that is called d block. I will give you example also. If last electron goes to f orbital, that is called f block. Let us take an example. Calcium. The calcium atomic number is 20. Its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. According to Abbas principle, first 4s has less energy, 4s less energy than 3d. First 4s filled, then goes to 3d. According to this, when 21, the atomic number is 21, then the electron goes to, here is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Since the electron enters to, last electron goes to d orbital, therefore the scandium 21 is called d block element. And the calcium 20, that is electron, last electron goes to p, 3s to p, s, that is called s block. P fill up ala, tapore s gala, the last electron goes to s orbital, therefore s block. Similarly, p block is fluorine, 1s2, 2s2, 2p5, fluorine. So last electron goes to p orbital, hence it is called p block. Similarly, if the last electron goes to f orbital, that is called f block elements. So the elements are classified into 4 types: s block, p block, d block, and f block. Out of this, I will teach you as for d block elements. So first you understand what is d block element, then d block elements are also called transition elements. Exception is there, it is called the transition elements. तादर कोटा transition element हो कोटा हाबने में कोई भी नेक्स्ट transition element. So the ground state, if the element contains ground state or any oxidation state, contain unpaired electrons in d subcell, then these are called transition. Then these are called transition elements. Then one is d block and the transition elements. Mostly so d block elements are also called transition elements. Now what is the name of the elements? What are the elements and position in the periodic table? Let us discuss name of the elements and position in the periodic table. First, scandium. Atomic number is 21. Titanium Ti 22. Vanadium 23. Chromium 24. Atomic number. Manganese 25. Iron 26. Cobalt 27. Nickel 28. Copper 29. Zinc 30. It is the 3D group. I मुझे भी था पढ़े 3D series or 3D series. Why name 3D series? I will discuss. Then 4D series. Deuterium Y. It is at number 39. Then zirconium 40. Niobium 41. Molybdenum 42. Technetium 43. Then ferrous, that is ferrous, ruthenium, all right, Ru is 44. So this is zirconium, 39, 40, 41, 42, 43, 44. Cobalt. In the cobalt case, that is rhodium, Rh, 45. Palladium, 46. Silver, 47. Cadmium, 48. So this is 4D series. Then go to 5D series. Lanthanum, 57. I am giving a star here. Hafnium, 72. Hafnium, this is your 72. Then tantalum, Ta, 73. Tungsten, 24. Technetium ପରେ ଆମର ଆସିବ Rhenium, Re, 74, 75. Ruthenium, iron, ruthenium. Then will come osmium, iridium, platinum, gold, mercury. 76, 77, 8, 7, 9, 8. At a number. Then 6D series. वो सबुरा कहबी गोटे खाली कही दूची. Actinium to RF. 89, it is 103. So it goes to, these are all belongs to 6D. So there are 3D series, 4D series, 5D series and 6D series. Among this, the most important we have discussed 3D series. जोटा कि परीक्षा बहुत समस्या in 3D series. Then we go to the electronic configuration. The general electronic configuration, general electronic configuration. General electronic configuration is n-1 D 1 to 10 ns 1 to 2. This is the question pachala the what is the general electron configuration of D block elements. Then you can write n-1 D 1 to 10 ns 1 2. Now in the electron configuration, this is scandium 21, 1s2, 2s2 scandium 21, 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. First 4s field, then 3d1. So you may write A like this, argon 18. So the 8, 8, 6, 14, 16, 18, 3d1, 4s2. The configuration of titanium, similar manner, it will be 3d2, 3d2 argon, 3d2, 4s2. Vanadium, 3d3, 4s3. Argon सेमती रहिला. Chromium exceptional, that is will be 3d5, 4s1. It is exceptional, important. The chromium very important, exceptional. It contains 3d5, 4s1. Similarly, we will here 3d5, 4s2, 3d5, 6, 4s2, 3d7, 4s2, 3d8, 4s2, 3d, it is exceptional, 3d10, 4s1 and zinc is 3d10, 4s2. So among this, the general formula n-1 d1 to 10 ns2, it began from 1 ends with the d10. So zinc contain 3d10 4s2, whereas scandium contain d1. Now let us discuss why the difference in chromium. Confession is chromium is actually chromium should be 3d 4 4s2. It is wrong. 3d 4s2. 3d 4 4s2. It is wrong. It is 3d 5 4s1. The confession of chromium 1s2, 2s2, 2p6, 3s2, 3p6. So 3d5 4s1, that is due to half-filled d orbital. Half-filled d orbital. The half-filled d orbital is most stable. As it is most stable, one electron from the 4s orbital comes to d orbital. d4, here is 3d4, we may write like this, 1, 2, 3, 4, 5, 3d, 1, 2, 3, 4, 4s2. In this case 3d5, 1, 2, 3, 4, 5, 4s2, 4s, 3d5, 4s, chromium confession, 4s1. So here we find this is half-filled, this half-filled are more stable. Why half-filled is more stable? One can say that is due to two factors. One is high exchange energy, that is stable. Why d5 is best, more stable? The half-filled or full-filled orbitals, the half-filled or fulfilled orbitals are more stable due to number one, high exchange energy, why it is more stable? High exchange energy, and second factor is symmetry. These two factors is responsible to bring the confession d5 and s1. But the copper chromium, if you write 4s2, 3d4, 4s2, then we will get 0 mark. It will be 3d5, 4s1. Similarly, copper confession. The copper confession will be 3d9, 4s1 bhul haba. It will be 3d10 outermost 4s2, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. Why? Similarly, we can find d9 and d10. 1, 2, 3, 4, 5. 3d, here is 4s2. And d10, ten 4s2, 4s1. Here we find this fulfilled. Fulfilled means the symmetry. It is highly symmetrical. So due to symmetry, high symmetry, it is more stable. Hence the confession will be 3d10 4s1, not 3d9 4s2. Exceptional. All other cases follow the order. Only chromium and copper, the most important electron confession will be 3d5 4s1, it will be 3d10 4s1. This is all about electron confession. General confession is that, and individual confession of 3d block elements, 3d series. Now go to size. When you go to size, it was found that size first decreases. First decreases, then remain constant, then increases. Exact value I will show you the size. I will give you the size. Size is scandium 1 point in picometer 1.44, 144, 144, 132, 122, chromium 117, 117, manganese 117, iron 117, 116, 115, 117, 125 in picometer. First we see the size gradually decreases, then remain constant, then increases. Here also we may yttrium Y, the size is 180, 160, 160, 146, 136, 134, 134, 137, 144, 154. In S block and P block elements, size gradually decreases, but here there is not gradual order, not correct order there. The order is either increases or decreases. First the size decreases, then increases. That is why. We know nuclear charge. There are two factors. One is nuclear charge, B2, depend on the three factors we will discuss. Skinning effect by d electrons, skinning effect, third, repulsion between pair of electrons, repulsion of electrons, repulsion of electrons. Now be interesting, if nuclear charge is more, then the attraction of nucleus toward the electron will be more, so the size will decreases. So addition of one electron, suppose scandium only one, D1, then D2, D3, D4, gradually d electron increases and one atomic number, one nuclear charge constantly increases. Hence, when the skinning effect and the nuclear charge balance each other, that means the size remains constant. Gradually, in zinc case, the size is more. That is why there is repulsion of, there is no unpaired electron, repulsion of electron pairs are there. Due to repulsion of electrons between them, the size increases. First, the size decreases due to more nuclear charge. When the nuclear charge is same to as a skinning effect, at that case, the size become same, then gradually increases. That is due to repulsion of electrons. So we can explain the size of the atomic size of d block elements by three factors: nuclear charge, skinning effect, and repulsion of electrons. So we get the size like this. Among these, question asked also why zinc, cadmium and mercury are not transition elements, are not transition elements. Because we find that in case of zinc, zinc atomic electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, zinc atomic number 30. So either in ground state, the ground state is the field, S1 the field. So every orbital is filled up. Zinc has only one state, zinc plus 2 state also. Oxygen state is 3d10. So does not contain any unpaired electron in d subcell. Hence, zinc is not a transition element. Therefore, same method we can explain why cadmium and mercury are not transition elements. But same method. Whereas other elements, scandium to copper, are called transition elements. Another point is the size. Size from scandium to yttrium, size increases. But it is increase color, it is increase color. It both come. Sometimes the size of molybdenum junction is almost same size. The size is same, can be explained by the introduction of here 57, 72. So there is 14 elements are there in here, where the electron goes to F4F subcell. Due to 4F subcell, as electron goes to here, and it is your 5F. 18 increase color, this to this size कमी जाऊँ कहीं देख this 4f the electron enter to 4f cell जेहेतु इलेक्ट्रॉन टा 4f के वजह जाऊँची after lanthanum this is called lanthanides. After lanthanum the elements are called lanthanides. 4f has pore shielding effect. Due to pore shielding effect of 4f subcell, therefore the nuclear size gradually remains same, not so increases. That is due to lanthanide contraction, which we will discuss in the F block elements. That is due to lanthanide contraction, which I will discuss later on. So this is all about your electron configuration and size. Now I want another point is there. What is melting point? Which is important. Among this group, the melting point of chromium group, chromium, molybdenum and tungsten. Tungsten is the highest melting point. And chromium, this group, 3D series, in 3D series, scandium, titanium, vanadium, chromium, like this, chromium has highest melting point. That is why. Why chromium has a highest melting point than vanadium or manganese or like this. You can explain this by taking electron configuration of chromium. Chromium is 1s2, 24, 1s2, 2s2, 3s2, 3p6, 3d5, 4s1. So it contains D subshell is partial field 1, 2, 3, 4, 5 3d and 4s1. 1, 2, 3, 4, 5, 4s1. जितना तक पिले सब को कंपेयर कले सब अनपेड इलेक्ट्रॉन remain maximum in this group chromium, molybdenum and tungsten, which group 3 to 12. This group comes 3, 4, 5, 6, 7, 8, 9 and 12. But on this group, chromium group has highest melting point. It contains 6 unpaired electrons. Unpaired electrons. What is in manganese? You find 3d 6 4s2. It will be 1, 2, 3, 4, 5, 3d 6, 4s2. So you compare this. It got 3d 5 4s1. It is 3d 6, 3d 6, 3d 5. Sorry, 3d 5 4s2. Here it contains 6 unpaired electron. Here it contains only 5 unpaired. जितना देखिले आप सब कंपेयर करिबा दिस ग्रुप chromium group, chromium, molybdenum, tungsten contains 6 unpaired electrons. More is the unpaired number of unpaired electrons, more is the interatomic attraction bond. Interatomic bond. It forms a interatomic atom with attraction metallic bond. Metallic bond formation into sodium row है, से वाला it forms interatomic bond. So hence due to it becomes strong and melting point increases. The particular palla scandium, titanium, vanadium, chromium, which is highest melting point chromium, because due to presence of 6 unpaired electrons, whereas कौन सी जगह रे ये तो 6 unpaired electron नहीं. Due to more number of unpaired electrons, more is the interatomic attraction. Interatomic attraction. Due to interatomic attraction between the atoms, it becomes stronger and the melting point increases. Now I will discuss the oxidation state only 3D group elements, that is 3D series. I will give you a 3D series का discussion करिबा. 3D series. 3D series remain in 4th period. This is 4th period in the period table. 4th period. Again I am writing only scandium, titanium, vanadium, chromium, manganese, yes, cobalt, nickel, zinc. Now we discuss variable oxidation state. Why the transition elements variable oxidation state? So variable oxidation state. So variable oxidation state due to availability of d orbitals and s, both d and s both D and S electrons takes part for the oxidation, both takes part. So here 3D1, 4S2, like this. The common oxidation state of scandium, the common oxidation state will be +3. Scandium, the oxidation state is +3. In titanium, it exhibits +2, +3, +4. More stability kotha pachare kohuchi. It contains scandium exhibit +3, it exhibit +2, +3 and +4. Vanadium +2, +3, +4 and +5. Chromium +2, +3, +4, +5, +6 chromium. Then manganese +2, +3, +4, +5, +6 and +7. Iron, mainly iron dekha +2, +3 mainly, and +4 is there. I am not writing because mostly +2, +3. Cobalt is called +2, +3, right? +4 like gold unstable. 2 plus nickel, copper is there, copper and zinc. Called +2, +4, am I right? Like this. Nickel +2, right? And +3, +4 stability I will discuss. Copper only +1, +2. But zinc only +2. Very interesting why scandium gives +3 only one state, zinc exhibit only +2. Zinc ra oxidation state variable dekhi paribani. Zinc ra only dekhai +2. First one is scandium. Let us discuss the scandium oxidation state. In the scandium, when the 2 electrons are removed, you take out the 2 electrons, it remains 3D1. Due to 3D1 easily removed, making the stable electron configuration, making stable electronic configuration of argon. It is argon 3D1 4S2. After the removal of the ionization energy, we take consider here also 2 and +1, 3 electrons we can remove. It again reaches the most argon, which is stable compound. Octet rule, it fulfills octet rule. Therefore, it exhibit +2. Titanium similar exhibit. If the electrons removed from s orbital only, that is called D2, 3D2, 4S2. When only 2 electrons are removed here from s orbital, that is +2. If 2 and 1, that is +3, and 2 plus 2 becomes configuration argon plus titanium +4. +2, +3 and +4. Among these, titanium chloride TiCl4 and TiCl3. So the pachara TiCl4, TiCl3 and TiCl4, which is more stable, then we can say Ti +4 state is more stable than Ti +3. That is because when you move 4 electrons, it attains the stable electronic configuration. Hence, Ti3 is there, Ti +3 is oxidizing agent or reducing agent. Question is asked you, is oxidizing agent or reducing agent? Ti +3 and Ti4, Ti +3 can form, it is convert to Ti +4. Itself is oxidizes. Since itself is oxidizes from +3 to +4, Ti +3 is a reducing agent. Hence, it is a reducing agent. The substance which oxidizes itself and reduces other substance is called reducing agent. Because Ti +3 and Ti4, we get TiCl4 and TiCl3, TiCl4 most of like this. Similarly, we can compare vanadium. The highest oxidation of vanadium is +5. Because +5 is there, after removal of 3D3, 4S2 argon, we get 5 electrons were removed, we get the configuration of argon. So, maximum number of electrons that can be removed from vanadium is +5. Chromium exhibit +2, +3, +4, +5, +6 like this. 3d5 4s1, so 6 electrons can be easily removed. After 6 electron removal, the maximum oxygen state of chromium is dash. But question the chromium as highest oxygen state is +6. So manganese 3d5 4s2 are gone. So it removed the electrons, 7 electrons. So hence it exhibits the highest oxygen is +7. Iron, similarly iron do the +2 and +3. One is ferrous chloride, another is ferric chloride. Similarly, cobaltic, +2 and +3 are the most stable. Cobaltous and cobaltic. Nickel exhibit +2, +3, and copper देखा +1 and +2. Kind +1 and +2 are exceptional. Copper shows +1 because composition is 3d10 4s1. Copper 29, 1s2, argon. I am writing argon. 18. 29. It is at 29. So if we remove 4s1 electron, it will be 3d10 compression, that would exhibit +1 and +2. But it was found that between +1 and +2 state in aqueous solution is more stable. But actually +1 but in aqueous solution deseparation. Due to deseparation of copper 2 change to copper 1 plus Cu. Change in aqueous solution. Therefore copper 2, copper 1 will be copper 2, copper 0. Because this copper 1 in aqueous solution can change to Cu +2, it is Cu +2 plus Cu0. So this is all about the variable oxygen state. Because zinc, there is only one oxygen state. How that kichhi nahi. Zinc ra tamara kichhi koi par. Zinc ra ZnCl likhi pariba nahi. Zn ra gote compound is there, ZnCl2. It is not a transitional element, hence it is contain 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. The maximum electron, 2 electron removal of 2 electrons, it attains this configuration, which is stable electron configuration. Due to stable electron configuration, zinc only can be removed 2 electrons +2, zinc remains as +2 state. So variable oxygen state, among these only manganese, the highest oxygen state is +7, chromium is +6, vanadium is +5, titanium is +4, so on. This is about the variable oxygen state. I am giving a compound V2O5. The V2O5, what is the oxygen state of vanadium? V2O5 is possible, V2O5 and V2O6. Which is it is possible or this is possible? In this case, we find oxygen state of vanadium is 2x minus 10, oxygen is oxygen minus 2 is equal to 10, x equal to 5. Here is 12 and +6 +5. So this is not, it doesn't form. It forms V2O5. Vanadium pentoxide. Formula is V2O5. The maximum state is +5. Then we go to formation of complex. Formation of complex. Okay, why transition metals form? Question is why transition elements? Why transition elements? Most of the transition elements, most of the transition elements, transition elements form complexes. Complex करिया पे हेले factor is number 1 small size. तीनटा factor. Number 1 small size of the cation, small size. Number 2 high charge. Number 3 availability of suitable orbitals, availability of d orbitals, that is availability of d orbitals for hybridization. So small size, high charge, and availability of d orbitals. So all the transition elements form a number of complexes. Titanium form a number of titanium H2O6 form a complex plus 3. It form a complex like this, titanium H2O6 plus 3. Having coordination number 6, titanium. Similarly, vanadium forms also complexes. Chromium, simple chromium, which I have discussed in the coordination chemistry, it forms complex like this, CrNH3 6 plus 3, which is ammonia is ligand, and chromium. Similarly, iron forms a number of complexes, Fe, CN4, K4Fe6. We may write K4Fe right, or we may charge directly K3, FeCN6, FeCN6. We may write or you may write this FeCN6 4 minus, FeCN6 3 minus. Nickel form number complex NiCO4, coordination of 4, NiCl4, NiCN4, like this. So number of complexes, all the forms, that is due to one small size and high charge and availability of d orbitals. Most of the transition elements form complexes. Then color. Why transition elements? Most of the transition elements are color. Kain color देखा देते कारण होची color. Most some पढ़कर पढ़े council पढ़कर why maximum नहीं पढ़े why most of the transition elements metal compounds transition compounds are color. Explain. They are color due to number one, why they are because color due to d transition. That is most point is d transition. What is d transition? I will discuss d transition. For scandium plus 1, the scandium plus 1, we can explain this by electron configuration 3d1, 3d0, that is configuration scandium plus 1, that is scandium. First write down the configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d0, 4s also 1 electron right there, 3d1, 4s2, scandium 21, 4s2. You find scandium plus 1 remains as 3d0 state. Since d orbital does not contain electron, hence there is no dd transition, no dd transition. Hence, this scandium plus 1 is colorless. I will give in the color. I will show different colors of some complexes. Scandium, titanium plus 4. Suppose question was titanium plus 4 compounds in aqueous solution, nominally aqueous solution, titanium plus 4 is colored or colorless. Titanium plus 4, its configuration is 3d0. Since it is 3d0, it is the color, it will be colorless because no division, it is colorless. Then titanium plus 3. कितना हो टाइटन प्लस 3 22 थिला हमर एटॉमिक नंबर इलेक्ट्रॉन पड़ेला पड़े टाइटन प्लस 3 Scandium plus 3 बर्तमान आमर केते स्कैंडियम एटा दुटा पळै दुटा 3d0 स्कैंडियम 21 जो हम करथिले स्कैंडियम 4s2 3d1 दी तीनटा को पळै पहला पर दिस कन्फर्मेशन देयर इज नो अनपेड इलेक्ट्रॉन्स देयर इज नो ट्रांजिशन स्कैंडियम सिमिलरली टाइटेनियम plus 4 and टाइटेनियम plus 3 टाइटेनियम plus 4 is confirmation 3d2 scandium is plus 3 state not plus 1 I have told you scandium this will be plus 3 state actually that is not plus 1 if 2 electrons also can be removed 2 plus 1 electron removed at 3 after removal of 3 electrons there is no unpaired electrons in the d subshell. So in the case of titanium plus 3 and titanium plus 4 you find out let us discuss titanium 1 is to titanium first write down titanium 1 is to 2s2 3s2 3p6 4s2 3d2. Now titanium plus 4 is color or color not colorless. So again the outer electron remove the electron s again s electron पड़ेगा तापर d. So the total number of electron removed from 2 electrons from s orbital and 2 electrons from d orbital 3d orbital. After removal of these two and these two 4 electrons can be removed. Titanium plus 4 will be decomposition will be 3d0. Since there is 3d0 there is no orbital in d subshell that no transition is possible therefore no dd transition hence it is colorless. गोटे एनर्जी यदि विजुअलाइजेशन आम कले विजुअलाइजेशन कलर वी फाइंड द कलर देन आई विल डिस्कस टाइटेनियम plus 4 color टाइटेनियम vanadium plus 3 let us discuss vanadium plus 3 is color or not vanadium plus 3 question may ask you why the vanadium plus 3 color or not titanium plus 3 that is 3d1 titanium 3d1 because 4s2 3d2 you remove 3 electrons you remain 3d1 1 electron there is 1 electron there all the d orbitals not same energy it can transfer from one low level to high energy level when the electron jumps from low energy level to high energy level then we get color so 3d1 titanium plus 3 color is purple color तार complementary color visual radiation absorb करिवो तार complementary color V plus 3 will be let us see its color is green. Why vanadium plus 3 in aqueous solution is green color? You will explain vanadium configuration is 1s2 2s2 2p6 123 vanadium atom number is 23 first item 23 1s2 2s2 2p6 3d4s2 2s2 2p6 तापरे 3s2 3p6 4s2 3d कितना सको 3d3 so vanadium plus 3 question asked it contain how many d electrons when vanadium plus 3 is there it removed 2 electrons from 4s orbital and 1 electron from d orbital giving configuration 3d2 since that 3d2 is there d electron which is partial field so that is possible of dd transition hence the color is green. Similarly you can find number of colors ferrospheric ferrous Fe2 plus and Fe3 plus Fe2 plus and Fe3 plus it is 3d6 4s2 3d5 4s2 it is after removal of 2 electrons the configuration will be 3d6 1 2 3 4 5 6 here is F plus 2 3d6 here will be 3d6 4s2 it is 3d6 4s2 2 electrons and 1 electrons it will 3d5 F3 plus 3d5 1, 2, 3, 4, 5. So, you find it contains 4 unpaired electrons, or 5 unpaired, so there is also possible DD transition. And due to DD transition, all the compounds of transitional metal compounds, most of the transitional elements are color. Now, whether zinc sulfate, zinc compound are color or colorless? Question sometimes asks why zinc compounds are colorless or color compounds. Simple way, write the electron configuration. First write the electron configuration. Zinc atomic number 30, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. 3d10. Zn plus plus, it will be configuration 3d10. Since d10, all the orbitals of d subshell are filled up. Due to d10 configuration, all the orbitals fill up, hence no transition is possible. Therefore, zinc compounds are colorless. Scandium plus 3 is colorless. Zn plus 2 is colorless. Why? We can explain by taking electronic configuration. Then last, the magnetic properties. We will discuss the magnetic properties. What are the magnetic properties? You simply remember, if it contains unpaired electrons means attraction will take place to the magnet, that is called paramagnetic. Simple, paramagnetic. If all are paired, no unpaired electrons, no unpaired electron, that is dimagnetic. It is dimagnetic. Now, we can explain which is paramagnetic and which is dimagnetic, giving the value is giving. Suppose scandium, we take scandium plus 3. It's paramagnetic or scandium. Value reka khali koi douchi, simple way. We can calculate this by taking the number, calculate the magnetic moment. Magnetic moment can be calculated as n plus 2 root over Bm. Bm is Bohr magneton unit. N is the number of unpaired electrons. Simple way you can calculate. Very simple. Number of unpaired electrons. Let us say scandium. Let us discuss scandium plus 3. Scandium plus 3. What is the magnetic moment of the compounds of scandium plus 3? Question asked you, scandium plus 3 magnetic moment kette? So, scandium magnetic moment configuration was 1s2, similar manner 2s2, 2p6. Only electron configuration is important, mostly important. 3s2, 3p6, 4s2, 3d1. The scandium. Plus 3 means 1s2 like this configuration. These electrons can remove. Again 4s gala removed. After removal of these electrons, we get 1s2, 2s2, 2p6, 3s2, 3p6. Hence, this does not contain any unpaired electrons. Unpaired electrons. Number of unpaired electrons is 0. Number of unpaired electron is 0. If number of unpaired electron is 0, 0 into 0 plus 2, that is equal to 0. So, scandium plus 3 is, there is no magnetic moment. Hence, it is dimagnetic or paramagnetic. It will be no magnetic moment, it will be no dimagnetic. Because the magnetic moment is 0. Now another example you take titanium plus 3. Titanium plus 3. In titanium plus 3, in D1 thila, it will be 3D2, 4S2. It will be confusing in 3D1. You take 3 electrons. After removal of 3 electrons, removal of 3 electrons, it's confusing 3D1. It contain number of unpaired 3D. 3D now it contain only 1 electron unpair. Hence, its magnetic moment now is equal to n plus 2 root over will be that is equal to 1 plus 2 that is 2 plus 3 equal to root 3. Root 3 value is 1.73. That is the value of titanium plus 3. তাহলে আমি একটু টেবল করে দেবো স্ক্যান্ডিয়াম প্লাস 3 magnetic moment is the mu is equal to 0. Then titanium plus 3 it is 1 point পাখাপাখি এক্সপেরিমেন্টালি আমি দেখিলাম পাখাপাখি ভ্যালু আসছে bm magnet. Similarly you take vanadium plus 3. What will the magnetic moment of vanadium plus 3? Vanadium plus 3, similarly we may write vanadium 4s2 3d3 outer 3d3 4s2 vanadium plus 3. Question was asked vanadium plus 3. If question asked vanadium plus 3, then 2 plus 1 only remain as configuration will be D1, it will be D2. Due to presence of D2 electrons, firstly singly occupied electrons Hunsul answer I go to dita raile 2 electrons, it contains 2 unpaired electrons n plus 2 n plus 2 that is equal to 2 plus 2 root over which is equal to root over 8. The value of root over 8 is equal to 2.83. 2.83. This is the magnetic vanadium. Then we go to chromium. Chromium plus 3. Let us ask chromium plus 3. Chromium plus 3 configuration is 3d5 4s1. Or take out electron 1, here is 2. Chromium plus 3 will be 1 and take out 2 remain as D3. D3 means n is equal to 3 plus 2 root over that is equal to root of 15. The value of root of 15 is equal to 3.87. Chromium 3.87. Manganese plus 2. Both basic of magnetic. Okay, which is more higher? Chromium plus 3 and manganese plus 2. Which has higher magnetic moment? Here is D5. No confusion got D5. It will come 5 plus 2 root over that is equal to root over 35 that is 5.92. Ferrous plus 2 which is and ferrous plus 2 ferrous plus 3 which has higher magnetic moment. If the question asks between ferrous and ferric compounds which has higher magnetic moments, you see it contains 3d6 4s2. It configuration general configuration. I remove 2 electrons 3d6. It will be 3d5. So it contains number of unpaired electrons 4. It contains number of unpaired electrons 5. Number of n is equal to 4 because 3d6. Look at here. 1 2 3 4 5 6 plus 2 state dita electron per each. और वही लगे थे चार्टा 4 unpaired electrons. Presence of 4 unpaired electrons, it will be n is equal to 4 n plus 2 root over that is 4 plus 2 root over we will get 32 root over 32 root over 30 root over 32 or 24 24 6 24 24 root over The value of 24 root over is 4.90. And the ferric, it contains 5 1p electrons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the value will be 5 plus 2 root over, there is root over 35, that is equal to 5.92. If the question asks which have higher magnetic moment between ferrous and ferric, you can easily answer that ferric ion has more magnetic moment than ferrous due to presence of more number of unpaired electrons. By this method, we can calculate the magnetic moment of all the elements present in the transition elements. Then I will discuss the compounds of two compounds which are in a course: potassium permanganate and dichromate. Potassium dichromate, K2Cr2O7 compounds and Chem4. Today I will discuss only some of the parts of potassium dichromate, compounds of potassium dichromate. The potassium dichromate K2Cr2O7. First, we can find out its oxidation chromium here. The chromium oxidation number we can find out Kl plus 1, plus 2, plus 2x, each oxygen minus 2, minus 14 is equal to 0. So 2x is equal to plus 14, minus 2 is equal to plus 12. So x will be plus 6. Here chromium remain as plus 6 oxygen state. Plus 6 oxygen state. So this can prepare from chromo iron stone. We can prepare this compound potassium dichromate from chromo iron stone, which formula is FeO Cr2O3. By we may write like this, FeCr2O4, or we may write FeCr2O4. See the chromo iron stone. Taking the chromo iron stone, first we convert this to sodium chromate, Na2CrO4. First step, you convert this chromo iron stone to sodium chromate. Sodium chromate. First convert sodium chromate can be done by addition with sodium hydroxide with oxygen. When it was heated with chromo stone, sodium hydroxide and oxygen, we get sodium chromate. Second step, first step, mone rakhibo, chromate stone, prathame by sodium chromate. Second step, conversion of sodium chromate to sodium dichromate. Sodium chromate to sodium dichromate. This can be done on treatment with acid, Na2Cr4. When treated with acid, sulfuric acid or any acid, we get Na2Cr2O7, sodium dichromate. Our aim is to find out potassium dichromate. Third step, sodium dichromate when treated with potassium chloride, we get potassium dichromate. So by this way, we can prepare by the conversion of chromo iron stone to sodium chromate to sodium dichromate. It is called sodium dichromate. Sodium dichromate. From sodium dichromate to potassium dichromate. Okay, do number question pare boson 2 number mark. Write the preparation of potassium dichromate from chromo iron stone. You take 3 steps. Now the structure of this dichromate like this, Cr, O minus, right? Is it like the O minus? Sorry, O minus. So this is one tetrahedral structure, CrOO. This oxygen remains bridge between two chromium atoms. It is a one tetrahedral part. It is O minus. The theta minus it is O minus. So it form like this, Cr tetrahedral. It is also, this structure is also a tetrahedral structure. Theta tetrahedral structure मिसिगला we get the structure of dichromate. By we write like this, Cr तीनटा O लिख दे पारे हम this तीनटा O total is -2. In the next class, I will teach you its reactions of potassium dichromate, subsequent like potassium permanganate and red block elements. Thank you for patient hearing. बंद